Look around your room. Almost everything you see, including this device you're watching on, traveled thousands of miles through an invisible, highly synchronized global network to get to you. Take a laptop. It is an assembly of dozens of individual components, each engineered and manufactured on completely different continents. The process begins with raw extraction. You have to blast rare earth metals out of terraced rock walls and pump petroleum from deep underground just to source the materials for a single motherboard. Those extracted materials are loaded onto bulk carriers and shipped across oceans, converging in specialized manufacturing hubs primarily located in Asia. Components are built in these specific locations because they offer immediate access to concentrated pools of skilled labor and natural resources, keeping production costs low. Manufacturing a simple consumer device is a carefully choreographed global ballet, operating entirely out of sight to deliver modern convenience. Historically, global trade was severely bottlenecked. Moving goods meant armies of longshoremen manually sorting and packing individual crates, barrels, and sacks into the hulls of ships. Then, in the 1950s, Malcolm McLean standardized the intermodal shipping container. By putting cargo into uniform steel boxes, ships could be loaded rapidly by crane instead of by hand. Today, those steel boxes transport between 80 and 90% of all global trade across sea routes. To handle this massive volume, we constructed sprawling coastal terminals packed with endless rows of containers waiting to transfer to rail and truck networks. But observe the density here. Thousands of packed containers sit right at the water's edge with virtually zero overflow space. These massive hubs operate as singular geographic choke points. Standardizing the steel box created a frictionless global conveyor belt, but it concentrated heavy risk into a handful of narrow coastal valves. Once inland, the physical boxes enter a modern distribution center, integrating with digital tracking networks. Inside, automated storage and retrieval systems maximize vertical density. Mechanical lifts operate within dense grids of bins, instantly finding and extracting exact inventory. Down on the floor, autonomous mobile robots navigate directly under shelving units. They bring the entire shelf to the worker, stripping human walking time out of the fulfillment process. But the automated flow stops at the edge of your neighborhood. This final stretch, the last mile, is the most expensive and least predictable phase because it involves moving individual items to thousands of unique residential addresses. The robotic efficiency stops at the loading dock. Delivering these packages requires human drivers to manually haul boxes through unpredictable traffic and suburban sprawl, working at the physical pace of an industrial athlete. We constructed a multi-billion-dollar automated hive, only to rely on exhausted humans to carry the goods across the finish line. For decades, the guiding philosophy of this entire network was to minimize storage and labor costs through hyper-efficiency and lean inventory management. Companies stripped out excess warehouse space to save money. In doing so, they eliminated their safety buffers, leaving the global grid extremely brittle. When a localized failure occurs, like a massive container ship wedging itself sideways in the Suez Canal, the resulting backlog paralyzes the system globally. The global machine achieved perfect mathematical efficiency on paper, but it completely failed to account for real-world chaos. Now, major corporations are absorbing higher operating costs to guarantee their products actually survive disruptions and make it to shelves. They are adopting a strategy called nearshoring. Instead of relying on a single distant manufacturing center, they are building production facilities closer to the final consumer in North America and Europe. Businesses are also abandoning lean operations to hold strategic buffer stocks, but keeping these products in more locations makes the logistics far more complicated to track. To manage this, companies are treating information itself as a tradable asset. This diagram shows how marketization of data drives technological innovation. Machine learning models forecast demand, eliminating the sudden production spikes known as the bullwhip effect. By focusing on predictive and adaptive capabilities, the network processes real-time variables, instantly rerouting logistics to bypass delays. The supply chain is shifting away from being a rigid physical pipeline and toward a system that uses data to detect disruptions and adjust its own routes before a delay can ripple outward. Which brings us back to the laptop on the desk. Every time you click buy, you activate a highly calibrated symphony of heavy industry, robotics, human labor, and artificial intelligence. Our modern convenience rests completely on a system that must constantly evolve to outsmart global chaos just to deliver a cardboard box to your door.